Industrial robots are programmable machines used for material handling, assembly, welding, packaging, painting, testing, and similar operations in manufacturing processes. They have features such as high precision, strong lifting capacity, and the ability to repeat tasks. Industrial robots are categorized as dangerous machines. Due to their ability to reach high speeds and force values, industrial robots can cause hazardous accidents. According to the Machinery Safety Directive 2006/42/EC, industrial robots are defined as partially completed machinery, and the assessment of risks should be carried out together with the integrated systems and machines. Thus, safety measures are necessary to protect operators and personnel working in the vicinity of industrial robots from accidents. Accidents caused by robots that are mostly involved in automated systems usually occur during times of human interaction, such as programming, testing, inspection, and maintenance. To prevent such accidents, in compliance with international safety standards for robots, they should be equipped with functional safety equipment like safety sensors, safety switches, safety relays, and emergency stop systems. The safety assessment of industrial robots and integrated systems is conducted in accordance with the requirements specified in ISO 10218. This training content has been developed to be suitable for a system that works in conjunction with a robot. The safety assessment may vary for different robot systems. Guards, safety distances. Depending on the height and width of the industrial robot system examined, the robot's surroundings can be enclosed with fixed guards. Safety distances, in accordance with ISO 13857, should be established between the guards and the robot to prevent access to the robot's workspace. These distances should be determined considering the restricted working area of the robot. Fixed guards should be designed per the relevant standard and installed in a way that can only be opened with special keys by authorized personnel. Easy-to-remove fasteners should not be used during the installation process. The color of the fences on the guards should be dark to enable the operation to be monitored. The height of the fences from the ground should prevent access to the robot's workspace by climbing or reaching. The fence height should be at least 2000 mm for the robot system examined in this module. Additionally, the distance between the bottom edge of the fence, also known as the creep zone, and the ground should not exceed 180 mm. In the presence of personnel within the robot's workspace, to prevent trapping, a safety zone of at least 500 mm should be left between the robot's maximum reachable point and the fences. The openings on the guards should be designed to prevent access to the robot's workspace by limbs such as hands, arms, and fingers. Therefore, the dimensions of the openings on the guards should be determined in accordance with the Safety Distances Standard Table 4, to prevent danger in accessible areas. Attention should be paid to the openings between the robot's workspace and the guards during the installation of the guards. For example, slot-shaped openings between 20 mm and 120 mm can allow access to hazardous movements within the arm's reach, 850 mm. Therefore, the gap size of the fences should prevent access to the robot's workspace. Maintenance door. Industrial robots require periodic maintenance. In case of a malfunction, authorized personnel may need to enter the robot's workspace. The maintenance door should be equipped with an interlock switch compliant with the EN ISO 14119 standard. Before entering the robot's workspace, the operator presses the door request button located near the interlock switch. After the robot completes the ongoing task, it returns to the home position and stops working. Once all the moving equipment and the robot inside the cell are stopped, the interlock switch lock can be released. Before entering, the operator attaches a personal padlock to the end actuator of the interlock switch. Thus, while the operator is working in the robot's workspace, others cannot close the door and activate the system. If multiple operators need to enter the workspace, each operator must attach their padlock to the interlock switch before entering to prevent the system from being activated without all operators leaving the workspace. After completing their work inside, the operator removes their padlock, reattaches the switch, and then presses the door reset button and locks the interlock switch. The operator starts the robot only after this procedure is complete. Escape function. The operator may forget to attach the padlock when entering the robot's workspace. Another person who is unaware of the operator working inside may lock the door. Hence, the door locks should be unlockable from the inside. Light curtain. The loading and unloading of products to and from the robot are manually done through an open area on the side of the robot. To prevent access to the robot's workspace through this opening, a light curtain can be used as a protective device. When selecting a light curtain, parameters such as the height of the protective area, resolution, and operating distance of the light curtain are important. Access to the hazardous area should only be possible by violating the light curtain. The light curtain should not allow passage or access to the robot's workspace from below or above. The light curtain used should be Type 3 or Type 4, and the resolution should be determined based on the application type and installation position. To determine the distance of the light curtain from the hazardous area, measurement of the robot's stopping time, t-value, and calculation of the safety distance based on the approach speed of body parts should be carried out in accordance with the placement of protective equipment based on approach speed standard. Control system. According to the Machinery Safety Directive, it is necessary to ensure that a malfunction in the hardware or software of the control system does not lead to hazardous situations. All safety equipment on the machine should be included in the control system in accordance with the requirements of the safety-related components of the control system standard. The reliability of safety circuits is determined by performance levels, with PLE, performance level E, representing the highest level of reliability. According to the safety requirements standard for industrial robots, the performance level of the safety circuit for the light curtain should be at least Category 3 PLD, performance level D. Robot programming. It may be necessary for the operator to be present within the robot's workspace during the determination and programming of the robot's operating parameters. Here, the operator uses a programming pendant called the teach pendant. In manual mode, during activities performed within the limited safety area, the robot can be moved at a safe speed as long as the activation switch on the teach pendant is pressed. The safe speed for robots is 250 mm per second, and the robot should not exceed this speed when programming is done within the limited safety area. During programming activities performed using the teach pendant in manual mode, where multiple individuals need to be present within the limited area, each person should use a 3-position enabling switch, enabling device, to ensure that robots' movements do not pose a danger to others.